Welcome to our circle theorem proofs. We want to prove that the angle between a tangent and a chord is equal to the angle subtended by the chord in the alternate segment. Step 1, we create the problem by drawing a circle and marking its center. We then need to draw a tangent to the circle and connect the point where the tangent touches the circle to two further points on the circumference of the circle, the first to form a chord and the second to form an angle which subtends this chord. We will label these points A, B, and C. We want to mark on angle A, which is the angle between the tangent and the chord in the minor segment, and B, which is the angle subtended by the chord at the circumference in the major or alternate segment. Step 2, we want to prove that angle A equals angle B, and we can do this by applying some of the other circle theorems. Before we can do this, we need to draw in our radii from points C and A to the center of our circle, and we can see that we have formed an isosceles triangle, and we can mark the angles between the chord and each radius as angle x. If we apply the circle theorem that states that the perpendicular bisector of any chord of a circle passes through the center of the circle, we can create two congruent right-angled triangles, and we can mark the angle at the center of each triangle as y. From the circle theorem that states that where a tangent meets a radius, the angle between them is always 90 degrees, we know that a plus x equals 90 degrees, and we can rearrange this so that a is equal to 90 degrees minus x. We also know that the sum of the angles of a triangle is equal to 180 degrees, and so we know that x plus y plus 90 degrees equals 180 degrees. And if we rearrange this in terms of y, we get y equals 90 degrees minus x. And so we can say that a equals y. Now we need to use another of our circle theorems, which states that the angle subtended by an arc at the center of a circle is twice the angle subtended at any point on the circumference. And so this means that the angle at the center, which is 2y, can be written in terms of b as 2b. So we can say that 2b equals 2y, and simplifying this we get that b equals y. We already found that a equals y, so we can now say that a equals b. And so we have therefore proven that the angle between a tangent and a chord is equal to the angle subtended by the chord in the alternate segment.